This is the Vehicle Penetration Test Senior Design Project, presented by Ethan Frenza, Jason Joseph, and Justin Reames, with advisor Victoria Walters. We are students in the Department of Applied Computing of the College of Computing. For this project, our group explored different possible vulnerabilities that could be found within a vehicle. Our goal was to test the simplicity, repeatability, and cost-effectiveness of attacks that could be implemented. We chose this topic as we wanted a chance to explore using the techniques and knowledge we have acquired while at Michigan Tech. We decided upon a mutually interesting and exciting project that would provide a challenge yet still be achievable. This project was not something that we had knowledge of beforehand, so we chose this to both learn new material and how to apply new strategies.
Our attacks included manipulating the CAN bus, IP packet manipulation, key fob RF signal, and RFID cloning. We focused on non-intrusive attack vectors to ensure the integrity of the vehicle was maintained. The Controller Area Network, or CAN bus, is a standard design for allowing microcontrollers and devices within a vehicle to communicate with each other without a host computer. Most vehicles have a port to access the CAN bus to receive diagnostic data from the vehicle, known as the Onboard Diagnostic or OBD port. Here we attempted to pick up packets being sent on the CAN bus, then tried to modify and inject them back into the bus. However, our hardware, while being the correct physical port standard, was unable to send or receive messages from the CAN bus.
The testing vehicle possessed the ability to be started remotely via an app. Since the app used TCP/IP protocol, we attempted to capture the data packets that included these start commands via Wireshark. Unfortunately, due to network congestion and hardware limitation of our wireless adapter, we were unable to isolate the proper Wi-Fi channel to capture solely the remote start app data packets. Modern key fobs for vehicles equipped with keyless entry include the ability to start the vehicle even if the fob battery has been depleted. The operation of this method involves setting the key in the center console so that an RFID signal can be read from the fob so that the car can be started. We attempted to use the Flipper Zero to clone the RFID signal from the key fob. Unfortunately, this attack did not work as the Flipper's RFID library did not include support for the RFID chip found within the key. Initially, we attempted to hijack and replay the unlock RF frequency sent by the key fob. This attack, known as a roll jam attack, uses a jamming RF source and a capturing RF receiver simultaneously. Unfortunately, this implementation of RF exploitation was found not viable due to a hardware limitation found within our software-defined radio devices. Fortunately, we were able to mimic this attack conceptually by using the Flipper Zero to capture the RF key fob unlock frequency outside of the receiving range of the vehicle, then replaying it back near the vehicle. This attack was successful and we obtained access to the vehicle without using the key fob directly.
In history, it has always been shown that a determined attacker will always find a way, but the fact that so many of our attempts were unsuccessful shows that the barrier of entry is high. Any common person would not have the skills to execute a non-destructive attack with minimal preparation that would allow them any access to a vehicle. So given the research put into this project, it seems most modern vehicles are relatively, but not necessarily completely, secure. As this project was mainly study and research focused, paths forward are minimal. Future research on the subject would depend on the desires of the students. Should any future students want to pursue this project deeper, then we would recommend having tools with greater capabilities, such as the Hack RF1, which allows for both receiving and sending of RF signals, compared to the SDR we had during our test, which was receive only. Improvements like this would allow for higher quality testing to take place.